the centrifugal compressor, which uses non-positive displacement vapor compression for compressing large amounts of refrigerant and are typically used in very large capacity cooling systems. A centrifugal compressor has three basic components: an impeller, a diffuser, and a volute casing. Large capacity centrifugal compressors may have two or more impellers or stages in the same casing. Centrifugal compressors are usually driven by hermetic electric motors. However, open-drive centrifugal compressors are also available for applications using steam turbine, gas turbine, or engine drives. The impeller is a rotating circular disc with curved blades that is driven at high speed by the electric motor. As the impeller rotates, it moves refrigerant vapor from the suction opening in its center to the outer edge using centrifugal force. The vapor enters the suction at a relatively low velocity and leaves the outer edge of the impeller at a high velocity. This means that the impeller transfers its rotational energy to the vapor, but high velocity does not relate to high static pressure. To achieve the desired pressure increase, or compression, the vapor must be slowed down, converting its velocity pressure to static pressure. That's where the diffuser comes in. As high-velocity vapor moves radially outward through the diffuser, the flow area increases, slowing the vapor and increasing the static pressure. Some centrifugal models have diffusers with vanes or pipes which change flow direction and further slow the vapor. The volute-shaped casing collects the slow-moving, high-pressure vapor from around the diffuser and conveys it to the discharge connection of the compressor. Inlet guide vanes control a centrifugal compressor's capacity. These movable vanes are located in the suction opening. With vanes turned fully open, the compressor produces its full cooling capacity. As the vanes are closed, they reduce refrigerant flow through the compressor, reducing the capacity of the refrigeration cycle. In addition, capacity control in a centrifugal compressor can also be obtained by changing the rotating speed. This concludes our segment on the mechanical non-positive displacement vapor compression cycle using a centrifugal compressor.
To make an aircraft move forwards, we need a pushing force or thrust, which we create by making the air accelerate between the front and the back of the engine. This is basically done by the large fan at the front of the engine, through which air passes at a high rate. These are the various components of the CFM56. The fan, which is a large diameter propeller, the low and high pressure compressors with 13 stages, which step by step increase the pressure of the air as it flows through them. The combustion chamber, in which jet fuel is mixed with air and burnt. The high and low pressure turbines, in which the pressure of the hot gas is reduced as they drive the compressors and fan. There are 5 turbine stages, 1 high pressure and 4 low pressure. And finally, the exhaust assembly. The CFM56 is a high bypass ratio engine. The primary flow passes through the combustor, while the secondary flow passes only through the fan. 80% of the engine airflow accelerated by the fan is directed into the bypass duct and provides 80% of the engine's thrust. The primary flow passes in succession through the compressors, the combustor and the turbines before being ejected rearwards through the exhaust assembly. The air is compressed in the low and high pressure compressors, and its temperature can reach 450 degrees Celsius, after which it enters the combustor where fuel is injected and ignited. Burning the mixture of fuel and air brings the temperature up to 1700 degrees Celsius. Finally, the accumulated energy is extracted in the 5 turbine stages immediately after the combustion section. The pressure of the air drops as it passes through the turbines and makes them spin, and the turbines whose shafts ride within one another concentrically in turn drive the fan and the 2 compressors. The air is then expelled through the primary duct, joining the air from the fan stream. A turbofan is therefore a flow cycle engine. Air is compressed, then heated by burning fuel, after which it passes through the turbines, which drive the compressors and the fan.